Hello, you're very welcome back to day 2 of the ENDORSE conference, the European Data Conference on Reference Data and Semantics. Now, today is, as I say, the second day of our event, and I hope many of you tuned in yesterday for our great speakers. And I know many of you were tweeting about it and sharing on social media. We would love you to do the same again today. Please use the hashtag ENDORSE2021 and also watch out for tweets from these accounts from EU Law Data Pubs, EU Publications, EU_Open Data and EU Lex. And we also want to interact with you once again today via Slido. So let's have a refresh with an ice-breaking question. You go online to slido.com or sli.do. You just go in your browser. There's no need to download anything. And when you're there, you will be asked to include the event. That's ENDORSE 2021. You can see it on your screens there. Once you go there, I'm going there myself now as well, you will see there under the polls a question asking, did you enjoy the presentations you attended yesterday? And there's a few options there. You can say you were inspiring, instructive, or very instructive. I think I'm going to say very instructive. So feel free to vote. I'm going to leave that open and we'll come back in a little while to see what everyone thought of yesterday's events. Now, we covered a lot, from understanding the people data tasks ecosystem to the importance of knowledge scientists. We heard about how to implement good reference data management in organizations, metadata, classifying language, and the case for intelligent content. We also got a progress report for a corporate reference data management policy for the European Commission. Today's theme is a little different, although interoperability is always our watchword all this week. Today's theme is law as code. So we will start, as always, with a keynote speech. Feel free to send questions to our great speaker using Slido. There's a Q&A function there. Please do that. So, and with that, I am very pleased to introduce Serena Villata, researcher at the Centre National de la Recherche Scientifique. Serena, over to you.
Thank you very much. So I will start sharing my presentation. Here we are. You should be able to see it. Okay. Here we are. Okay. So I'm really pleased to have been invited to this great event, to this great conference. And I hope you will enjoy my talk. So in my talk, I will cover actually two different aspects that are strictly interrelated. So on the one side, knowledge representation for the legal domain, meaning mainly ontologies, legal ontologies, and then how we can really enrich information extraction methods with such a kind of semantic information which is contained in legal ontologies. So here we are. Let's start. So this work, the work that I will present you today, is of course in collaboration with other great people. So this work in particular has been done in collaboration with the University of Cordoba in Argentina, and in particular with Laura Alonso Alemany, Christian Cardellino, and Milagro Terrell, and also in collaboration with the University of Turin in Italy, with Luigi Di Caro and Valentina Leone. So, what are legal ontologies? Legal ontologies are ontologies whose aim is to represent legal knowledge, and of course, as I'm saying now, it seems something like something very precise, but of course legal knowledge is broad, and so many different fields in law can be formalized through ontologies and legal ontologies. So this is why also it is important to define in a way the semantic information that are behind the law. So why do we need to formalize such a legal knowledge? Do we really need it? Well, of course, yes, we need. We need to formalize legal knowledge in ontologies, for instance, in such a way to have machine-readable knowledge, where we know what are the main concepts of maybe a particular field of the law, where we know what are the relations between these different concepts And also we know what is the meaning, what is the meaning of each of these concepts. Having well formalized, let's say, deeply described legal ontologies is important, not only for the legal domain, but also for computer science, for now what is called AI and AI and law approaches. In particular, it is important to increase the automatic approach to the legal field, meaning that through these legal ontologies, we can actually enhance the information extraction from legal text, for instance. We can develop question answering systems for the legal domain. And we can go into even more complex tasks like the extraction of argumentative structures from legal text. Till the final, let's say, task, which is really achieving kind of automatic reasoning over, for instance, legal cases. Okay, so the idea is that we should start before by formalizing in a semantic, interoperable, machine-readable way the legal information. Then we can use it actually to, in a way, provide structured representation of what we have now in legal text, for instance, to then use all that for the automatic reasoning over legal cases and legal knowledge in general. So there has been a number, actually quite a lot, ontologies that has been developed thus far. So as you see in the references that I put in my slide, actually it is quite a while that scholars in philosophy, in law, but also in computer science, formalize the knowledge, the legal knowledge in legal ontologies. The first approach is like the one I listed here, so like the functional ontology of law, the frame-based ontology, the LRI core, the CLO core legal ontology, or the LKIF, and I will be back to LKIF soon, are ontologies which aim to provide a representation of legal knowledge, and they don't, let's say, really concentrate on a precise legal field, but they provide a more high-level representation of legal information. What happened more recently, in particular from 2010 and 10 on, is that there has been a lot of efforts in defining new ontologies, but they were more specifically targeting some legal subfields. And this is in a way, this shows a greater awareness of the specificity which characterize each of these legal subfields, because of course we cannot use the precise same concepts in the different legal fields. But on the other side, this also highlighted an issue that is an issue we know not only for legal ontologies, it is an issue that in a way spread for all this kind of semantic representation of information. So the fact that often there has been some concepts that have been redefined several times in the different ontologies dealing with more or less the same legal subfield. Meaning that we are back to the old good question, to reuse or not to reuse the data, but also these kinds of semantic structures. Meaning that when we need to define a new legal ontology, because we know that there is a lack of semantic representation for the particular legal field we target, then of course this means also that we need to check carefully what has been done before, what are the related legal ontologies that has been defined in the literature, and then we can maybe inherit or reuse some of these concepts. This makes actually these ontologies interconnected, This makes ontology more interoperable because, of course, through these links, we can move to one also legal field to another, meaning through their semantic representation. So this is really very, very important. However, the problem is also that it is quite hard to make a clear view of all the existing legal ontologies that has been published recently. So there is also this difficulty that impacts on the fact that sometimes new concepts are proposed, even if another ontology, I don't know, 6 months before proposed the same. So what we did, this is a kind of a quite recent work we have been doing with my colleagues in the University of Turin, is that we try to classify legal ontologies, in particular the most recent ones. And actually we let's say cluster them using five classes, five main classes dealing with the legal subfield they were formalizing. So on the one side we have the legal ontologies targeting policies, for instance. Then we have those targeting licenses. Then there have been a huge amount of legal ontologies dealing with privacy, in particular with the publication of the GDPR. That was also the raising, let's say, input for these new ontologies. Then there are two ontologies for tenders and procurements, and then some cross-domain ontologies, which are which are more high level, let's say, in their representation of the legal field. So they don't really target a precise legal subfield. And what we did, what we asked us, actually, it was something like, okay, now we have these ontologies, so how can we, in a way, structure an analysis of these ontologies along with some criteria that we can see they all share, or through some criteria that we can use to, in a way, assess what kind of knowledge these ontologies deliver. So we came out with this kind of, let's say, classification, let's call it like that, which is maybe not exhaustive, and maybe it could be also improved. But this is what we reached as an agreement after a number of discussions, and what we have also seen as key points in these existing ontologies that we analyzed. So what we have is that on the one side we have what we called the main features dealing the general information, and you can read this list. So there is the name, the legal domain, the purpose, the year of publication, the current version. Some of them may seem kind of straightforward features to analyze these ontologies, but actually they are quite important when you want to make really your ontology reusable, interoperable, also for the representation of the legal domain. Meaning that a clear description on what is the legal domain the ontology targets, it's important. And also the frequency updates is important. So knowing whether this ontology is kind of static and it doesn't change over 10 years, or if it has been updated to take into account recent amendments, that is important. Another kind of information that we could target is more what we call the modeling information in these ontologies. And this is also very important to gain a good understanding of what is inside these ontologies. Because sometimes, unfortunately, these ontologies have not a huge, let's say, documentation which comes with them, and so you really need to have a look at the classes that are defined, how they are defined, the different relations with the other concepts, and so there really it is important to extract such a kind of features. So, for instance, we were interested in knowing which was the knowledge source for the terms extraction. That is quite important. So, is it the GDPR, for instance, or is it another code? And then also, this is very important, in particular for operability. What are the external references to other vocabularies? So this was very important also to know how much these ontologies were interlinked with the other existing ontologies. When I talk, this is a side note, when I talk about the external vocabularies references, I don't mean forcefully references to other legal ontologies, but also to other ontologies, which maybe provide a better representation of a certain domain, of which the current ontology provide the legal characterization. Another two elements which are quite important are the design patterns that has been used to design the ontology, and also how and if this ontology has been evaluated. So that could be an evaluation using a kind of questionnaire that has been answered, or more kind of evaluation done by expert of the domain, but still some kind of assessment of the ontologies should be encouraged in this kind of formalization of the information. Another, and this is the final perspective we considered for the analysis of ontologies, was more the semantic information. So here we really go into the main aspects of legal ontologies, meaning what was the adopted normative model and what, if available, which was the deontic model they grounded on. So this is the kind of analysis we have been addressed on the ontologies that I've been showing before. And this is the kind of results we came up after this analysis. So, of course, I will not have the time to go too much into the details for all of these ontologies, but I will just pick some of them to provide you some details, in particular regarding the normative model and the deontic logic model. So in this part of our analysis, we really wanted to understand which was the normative model, which was the deontic model, and also whether the ontology was modeling the temporal aspects of the law, which is an important aspect in the legal domain. So, for instance, we have the CC rel ontology, which deals with the normative model we call the prescriptive rules, and which, from the deontic point of view, provides what are the requirements and the prohibitions set by the Creative Commons standard. And then we have more precise, for instance, definitions of what is inside the deontic logic model. So, for instance, if we consider legal rule ML, we see that it is quite rich in the modeling, both of the temporal aspects and of the normative model, because they take into account both constitutive, technical, and prescriptive rules. And then we have also quite a wide range of, let's say, deontic dimensions that are considered. So not only permissions, obligations, and prohibitions, so the standard 3 deontic modalities, but also what happens whether there is a violation of a prohibition or of an obligation, how we could reparate of a violation, we could reparate a violation, and so on. So, as you see, from such a kind of structured analysis of the different ontologies, we can really highlight what are the main features. And thanks to that, we can also make informative choices if we want then to extend one of these ontologies or use one of these ontologies in our algorithms, for instance. And then the same apply to the other ontologies we considered in our analysis. So, for instance, the PPROC ontology, which is about privacy. Then we have also other obligations to a contract, needs for tenders, for instance, and so on. And same for all the others. So, as you can see here, we have really a huge spectrum of information, of knowledge elements that are provided in these different ontologies. So we see that there is really a rich knowledge that is provided in a structured way. So now the point is to see how we can really use such a kind of knowledge to make kind of automatic approaches to the legal field. For instance, making an information extraction system. So this is what I will try to go into the details now. So the point which makes sometimes difficult to use these ontologies for instance, the information extraction task, which aim at extracting information from text to then maybe populate an ontology, is that these knowledge boxes, which are these ontologies, these legal ontologies, are very detailed, very rich in the semantics they provide to the different concepts in the legal domain. But on the other side, they are empty, meaning that these are they provide kind of the structure. But then we need to fill in this structure with elements, which are these elements which could extract using from information extraction methods to really populate these ontologies, such that we have that for each concept there are a number of instances which are concrete instances we have taken from text, and that actually populate this concept. So this is very important to improve also automatic approaches to the legal field, in particular to legal text, which is also my main domain of expertise. So if we want to extract entities from legal text, the problem is that there are a large amount of unannotated legal texts that are freely available. This is on the one side very good because we have this data available for us, but the problem is that this data is unannotated. I will be back to this point later on, but we need annotated data in a way, and the annotation is very costly, both from let's say the definition of how the annotation should be addressed, and in terms of time you spend really annotating this text. So there are very few annotated corpora for the legal domain, meaning textual resources where we annotate different kind of entities depending on our interest. It could be name entities, as what I will be talking about in the next few slides, or it could be something like arguments that are used there, or other elements, legal elements that we are interested in. So the point is that having these few annotated corpora, it doesn't help a lot in building this system, which are basically most of them based on supervised learning methods, meaning that they need annotated corpora to learn what they have to extract, and then we can apply these systems on new unannotated data. And the point is that through this process, we can also populate ontologies. And so we can enrich these ontologies with actual concrete entities we have in our text. So the problem is that this is very costly, as I said. And so what we try to do in the context of the name entity recognition, classification, and linking task was to provide kind of a, let's say, cheap approach to do that. Okay, so what is the task for first, just to let you understand? So this is a very, let's say, in a way, simple task in NLP. The idea is to identify the different entities, to recognize when there is an entity in the text, to classify this entity. Usually there are the classes of like population, place, organization, and so on. But then we can go into more fine-grained, let's say, name entities, and in particular name entities peculiar to the legal domain. And then the final aim is to link these entities that we identify in the text to entities in knowledge bases. So let's take, for instance, this very short sentence, because it has been cut, then I will go on into this analysis, which is the court is not convinced by. So the idea, what we want to do in an automatic way, is to say that the court, for instance, is the trial court, for instance, the WordNet trial court in the YAGO ontology, and then this is for the name entity recognition and classification, meaning that we first identify that the court is the name entity we recognize, then we classify it as being this kind of concept, and then we interlink it to, for instance, Wikipedia, where we link these to the page of the European Court of Human Rights. Okay, so this is what we aim ideally to do automatically, in such a way that then we can go into more complex tasks like question answering over legal documents, or argument extraction over legal documents. So what we did, very, very briefly, just to provide you the overall idea of what could be done to tackle this problem and what are the open issues that we still have, is that we have taken two ontologies. So one ontology, which is an ontology for the legal domain, the LKIF ontology. So it is an ontology with 69 law-specific classes. It is not populated. And we have taken on the other side a very general purpose ontologies, which is YAGO, okay? And YAGO provides an alignment to the Wikipedia through the Wikipedia, okay? And it is composed of millions of classes and entities. So what we wanted to do is we wanted to align these two ontologies in such a way to, in a way, exploit the general purpose ontologies to annotate in a cheaper way legal concepts through LKIF. So this is the outline of our approach in general terms. So the idea was to establish a mapping between these two ontologies. We selected the two. We manually identified and classified the name entities in the corpus, a Wikipedia corpus, using both the YAGO ontology and the LKIF ontology. And then, thanks to this annotation, we made a kind of alignment such that when we annotated with the same concepts, the same name entity, then we say these concepts are aligned. Then we scrap tagged examples from Wikipedia through the YAGO ontology, so the general purpose one, and then we train a name entity recognizer and classifier on those examples. So this is the kind of different levels we tackle. So the first level was, of course, this is a name entity or this is not a name entity, so kind of the binary classification. And then we go to the standard name entities, namely person, organization, document, abstraction, act. And then we mapped these with LKIF and with the YAGO. So in a way, the LKIF ontology gets populated by the linked entities from the YAGO ontology, so the one on the right, you see, highlighted it in blue. And then we have that YAGO gets additional semantics, additional legal semantics from LKIF. And so what we have is that we actually align 30 out of the 69 LKIF classes and 47 out of the 358 YAGO concepts to each other. So the point is that, again, and I'm here again on this issue, annotation is not trivial, okay? So even annotating Wikipedia articles with both the ontologies concepts, it was not trivial, okay? Because it's really time consuming. So through an example, I will show you what we have been doing to give you an idea of all that before concluding. So here we have the recognition of the name entities. So these are those that I put in bold. So this is done quite simply in the text. Then we want to classify the legal ontologies with standard name entities, meaning organization, abstraction, person. So we say that the court is an organization, the Court of Cassation is another organization. And then we have abstractions like judgment in legal activities, and entities, so person entities like entity. And then we want to classify these elements through the LKIF ontology. So we say that actually the court, which was an organization here, it is a public body. Same for the Court of Cassation. Actually, the judgment is a decision. 18 sen is a legal person, and illegal activities is a crime. And then we did that for YAGO as well, meaning that we say that for the court is a trial court, and then this is the URI, same for the Court of Cassation, and then we have that judgment is the concept judgment, 18 sen is a union, and illegal activities is in the concept illegality. And then what we want to go further at the end is to have these linking with actually the entities in the legal in the knowledge base in the Wikipedia. So meaning that the court is the European Court of Human Rights, the Court of Cassation in this case is the Court of Cassation in Turkey, and 18th Sen, for instance, is the Education and Science Workers Union in Turkey. So we did this alignment, and then we annotated also other documents, namely the European Court of Human Rights judgment, 5 of them. And as you can see, I don't want to hide these, the agreement between the annotators is quite low, meaning that at the end, this is again a very difficult task, in particular within the legal domain. And these annotators were legal experts, so it were not the computer science scientists who tries, let's say, to do this kind of task. So just I will go very quickly on the results, because anyway you can find them in the paper if you're interested in more details. So we performed quite well on Wikipedia, so training on Wikipedia and testing on the Wikipedia corpus we build. So both for the recognition, the classification, for LKIF and for YAGO. When we move to the European Court of Human Rights data, so actually here we really have a drop in performances, because of course the dataset is smaller, because it is costly to build these resources. And on the other side, the problem is also that the annotation was in a way less reliable. So the embeddings, these famous embeddings that now we always hear about, they didn't play really an important role on that. And when we move to linking, we just got very bad results on that. So still room for improvement. So even if I let's say presented you what is what we call an expensive ontology population method. So we have shown that it works pretty well when we go on the corpus that are huge corpus, of course, but then when we move to legal corpus, then results are lower in a way, even if it is still good, given the fact that we don't have really a very hard approach. So there are many future challenges. I just moved to the final slides before taking some of your questions. So what's left? What my take-home message is this. So on the one side, we have these legal ontologies, which are very precise, which provide the legal knowledge that we need to develop automated approaches like information extraction or question answering. But on the other side, we lack annotated resources, and we need really to have interlinking between these different ontologies in such a way that we can reach interoperability. So the two things we need are really transparency and interoperability for this kind of applications. And there are also use cases, like for instance, the online hate speech detection, where there are many different definitions of what it is hate speech. There are even let's say from a kind of legal point of view. So Twitter has its own list, and Facebook has its own description of how it is, and so on. Okay, and so it is difficult also to define the task from an automated point of view. So also in this case, kind of having ontologies, well-designed ontologies, would really help a lot. I think I will conclude with that. So thank you a lot for your attention.
Thank you very much, Serena. Now, we have seen a couple of questions come in, but I think we've probably time maybe for just one. Someone has asked, what about AI-created annotation? Also, somebody is asking, can you elaborate on the tools you've used for evaluating, annotating, and maintaining or enriching ontologies in the legal domain? Perhaps you could take those together just briefly before we go to our tracks.
Yeah. So actually to compute the in a way the agreement between the annotators, there are standard measures we could use. That's what we have in also for other tasks in NLP in general. Of course, we could go for creating annotations alone. Actually, this is, in a way, the aim of these name entity recognition and classification. So we want the system to learn how to do these annotations alone. But the problem is that for the moment, we are still, in a way, stuck into supervised learning approaches. So we do need annotated resources at the beginning. And to have these annotated resources, we need experts doing these hard annotation. So this is something for the moment we cannot escape. We can go towards semi-automated approaches for these annotation, but still we're still far from reaching the kind of fine-grained annotation and precision annotation.
Thank you very much, Serena. We are going to now break into our tracks as with yesterday, but first let's have a look at that Slido poll and see how much you enjoyed our tracks yesterday. Okay, absolutely, lots of you found it instructive and inspiring, so that's great, and the slightly negative comments got no votes at all, so that's good to hear. So we'll stick with that plan again for today. So let me remind you how this is going to work. There are 3 tracks that you can go into. If you've registered for one in particular, you will have the link in your emails. If not, just select them there on the screen. Track 1 is Law as Code. Track 2 is Fundamentals. And track 3 is Innovation. Now, for the rest of this afternoon in these tracks, we are going to take questions through the chat, not through Slido. Slido will be left open with a survey for you to fill out as and when you feel like it. We're going to leave that there for the afternoon. We're going to gather your thoughts via that in the Slido poll section. But for questions, because we have some great speakers and we do want your questions, use the chat function. So with that, we're going to take a moment now and let everyone get into their tracks.